Okay, people, let us solve this particular problem. Yeah, the first step for us in this problem are to write all the variables. So from the question, we have been given that the resistance force R depends on variables such as the length, the velocity c, the viscosity of the air mu, the density of the fluid, here it is air rho, and the bulk modulus of air k. Yeah, so this is what we have been given. Now let us express the functional relationship between these variables and the resistance force, shall we? Yeah, let's represent it mathematically. So I have written that R, yeah, the resistance force, is a function of L, C, mu, rho, and K. Of course, we do not know what is this function. It can be any function. We just know that it's a function of this. Now we call R as the dependent variable and L, C, mu, rho, and K as independent variables. Yeah. So otherwise R depends on all these other 5 variables. Yeah, so this is how I have written it as a mathematical expression. Now this can also be written as, yeah, all of them together as a function. Yeah, function 1 of R, L, C, mu, rho, and K equals 0. Yeah, now what are the total number of variables? Here the total number of variables is n equals 6. Look at this: 1, 2, 3, 4, 5, 6. Yeah, there are 6 number of variables, so I have written it as 6. Now let us find the number of fundamental dimensions that are associated with these 6 variables. Yeah, so what I'm going to do is I'm going to write the dimensions for all these 6 variables. So in order to find m, which is nothing but the fundamental dimension, let us write the dimension of each of these. R is ml power minus 2, velocity c, it should be c, yeah, is lt power minus 1, mu is ml power minus 1 t power minus 1, rho is ml power minus 3, and k is ml power minus 1 t power minus 2. But now what I would like you all to notice is there are only 3 fundamental dimensions: m, l, t. There is no other dimension: lt, mlt, mlt, ml. So the number of fundamental dimensions are 3. Yeah, there are no other fundamental dimensions over here. So in all these there are only 3 dimensions. So the number of fundamental dimensions, as I told you, is 3. So in order to find the number of dimensionless pi terms, otherwise how many pi's that there are, it is nothing but n minus m, where n is the total number of variables and m is the number of fundamental dimensions. So 6 minus 3, because we already found that the number of variable is 6 over here. Yeah, and so we are going to have 3 different pi terms. Yeah, so there are going to be 3 pi terms. I'm going to call these 3 pi terms as pi 1, pi 2, and pi 3. These pi terms are dimensionless, just to make sure you are all aware. Yeah, so now we have to go to step 2, which is selecting the repeating variables. Yeah, so we have totally 6 variables, and of these 3 of them are repeating variables. Yeah, because m is 3. So each of the pi term, my dear people, each of these pi term, pi 1, pi 2, and pi 3, yeah, they are going to have m plus 1 variable, otherwise 3 plus 1 variable, and this 3 is m is what is usually called as the repeating variable. Yeah, so out of these 6 variables over here, the out of the 6 variables over here, we have to select 3 repeating variables. We cannot select r as a repeating variable because it is the dependent variable, so we cannot select it. Yeah, and it should usually it is advised not to select. So out of the 5 remaining variables, yeah, one of them should have a geometric property, the second variable should have a flow property, and the third one should have a fluid property. Yeah, these requirements, if you think of it, are fulfilled by selecting L, C and rho as repeating variables. Yeah, otherwise the repeating variables themselves should not form a dimensionless term and should have themselves dimensions equal to m, that is 3 here. Yeah, so the dimensions of L, C and rho, if you think of it, are LT power minus 1 and ML power minus 3, and hence these 3 fundamental dimensions, they exist in L, C and rho, and they themselves do not form dimensionless group. Yeah, so if you did not really understand what I was saying, this is what it means. So I'm just going to write all the different pi terms here. Yeah, so pi 1, I'm going to write it as L power a, because the 3 repeating variables that we are selecting are L, rho and C. These are the 3 repeating variables that we are selecting. It means that pi 1 is L power a times C power b times rho power c times r. Yeah, so the non-repeating variable are r, mu and k. If these 3 are repeating, the other 3 are non-repeating. So pi 2 equals L power, let us say a, times C power b rho power c times mu. If you think of it, in pi 1 and pi 2, L, C and rho are repeating again. Yeah, whereas r and mu are not repeating. Similarly, pi 3, if I write it, what do you think? L power a times C power b times rho power c times k. So what I am going to do is I am going to look at each of the pi terms in terms of their dimensions. Is that okay? So let us just look at the first pi term. Yeah, each pi term we have to solve by the principle of dimensional homogeneity. Yeah, so let us look at the first pi term, pi 1. Yeah, so pi 1, pi is a dimensionless term, so we can write it as m power 0, L power 0, T power 0, because these are the fundamental dimensions that we have, equals, what is the dimension for L? Length is nothing but L, so L power a times, for C is L T power minus 1 times b plus times, for rho is m L power minus 3 times power c times, the dimension for r is m L T power minus 2. That's it. Yeah, I can put a bracket here. So now let us just look at all the powers of, we are just going to be looking at the powers, we are just going to be equating the powers. So first let us look at m. M power 0, L power 0, T power 0 would equals L power a times L power b here, yeah, times T power minus 1 times b is minus b times m power c times L power minus 3c times m is nothing but m power 1 times L power 1 times t power minus 2. All that I have done, my dear people, is that I have just expanded the brackets. Yeah. Now let us do the equating of powers. So for m, let us look at m. What is the power for m on the left hand side? It is 0 equals, there is no, let us find m. Okay, c and 1. Okay, so it is positive 1, so plus 1. So what does it mean? C equals plus 1 goes to the other side and becomes minus 1. That's it. Yeah, so we have identified what is the value of C. All that we have to do is identify the values for B and A. So first we have used M as a means. Now let us use T. If I use T, let us equate the power of T. 0 equals, let us find where is the T, minus B. Minus B, and I keep going, minus 2. So minus 2. So what does it mean? B equals minus 2. So we have found the value for C and B. Now if we use L, yeah, what is the power of L? 0 equals, here on the left hand, on the right hand side we have A plus B, A plus B, and keep going, minus 3C and plus 1. Yeah, now let us substitute everything that we know. We know the value for C and B, so let us substitute. 0 equals A plus B is nothing but minus 2 minus 3 times minus 1 plus 1. So 0 equals A minus 2 plus 3 plus 1. So minus 2 plus 3 is plus 1 is 2. So when it goes to the other side, A negative 2. So here we have found for pi 1 term, for pi 1 we have found the values for A, B and C. Now all that we are going to do is we are going to substitute these A, B, C values in the pi 1 equation, in equation number 1. Shall we? Yeah. So pi 1, I can write it as pi 1 equals L power A. A is negative 2. Let me just write the pi 1 term. Okay. L power A times C power B times rho power C times R. This is pi 1 term. See? This is what pi 1 term was all about. Now all that we are going to do is we are going to substitute the value of A, B and C here. So pi 1, I can write it as pi 1 equals L power A is negative 2 times C power B value is also negative 2 times rho power negative 1 times R. Yeah. So what does it mean, my dear people? It just means that negative term means it goes down. So R divided by L power minus 2 is L square times C power minus 2 is C square times rho power minus 1 is rho. So pi 1 is nothing but R L square C square times rho. We have to make a box of it. Yeah, this is what I have done to identify the pi 1 term. Now we have to use the same method to find pi 2 and pi 3. Yeah, let us use the same method, shall we? Okay, what is the pi 2 term that we know? Pi 2 equals L power A. I'm just writing exactly what it says here. Yeah, L power A C power B rho power c times mu. Yeah. Okay, now here for pi 2 terms, again we have to find out what is the value of a, b and c. We are going to use the dimensional analysis method again. Yeah. So what is pi 2? Pi 2 is dimensionless. So m power 0, l power 0, t power 0 equals, yeah, let us put in the dimensions for all of them. So L is nothing but L power A. Again, the dimensions for L, C and rho are not going to change. They are exactly going to be this thing here. Do you see? It's exactly going to be here. This thing. The only thing that would change is this value here. Because here, it for pi 1 it was R. Now it is mu. Is that okay? Yeah? I know this is a bit long winded, but trust me, it's really easy. Yeah, it's just taking a lot of steps, but it's just algebra. So, what is the dimension for velocity? It is L t power minus 1 times b times rho is L. What is it? Even I forgot. What is it? It is m. It is m l power minus 3. Well, you don't have to remember it, times c times mu. The dimension for mu is m l power minus 1 t power minus 1. Yeah. So now I'm going to expand the brackets, my dear people. So m power 0, l power 0, t power 0 equals L power A times L power B. L power B times T power minus 1 to the power B is nothing but T power minus B times ML power minus 3 whole power C is nothing but M power C times L power minus 3C times M L power minus 1 t power minus 1. Yeah. So now let us equate the powers on both the sides. So what do we have? Yeah. Let us just do it for m first of all. Okay. So m is 0 on the left hand side. Right hand side, let us find all the m terms. Okay. We have two m terms. C and the power here is 1. Is it not? Plus 1. So what does it mean? C equals negative 1. It is that's it. Yeah, C is negative 1. So now let us look for T. Yeah, T is 0 equals, let us see all the T terms, minus B and minus 1. Okay, so minus B minus 1. Yeah, so what is B? B equals negative 1 again. Yeah, it's just rearranging of equations. So I have found out both C and B. Now we have to find A. How can we do it? We can put it in L. So let us look at all the powers of L. On left hand side it is 0 equals, what is the power here? A, and here it is plus B, and then to L minus 3C minus 1. That's it. Are we missing anything? Let's see. L is A plus B, and then it is minus 3C and minus 1. That's it. Yeah. So now let us substitute the values of C and B in this equation, shall we? So 0 equals A, B is minus 1, minus 3 into minus 1, minus 1. Yeah. So 0 equals A, negative 1, this is plus 3, minus 1. So 3 minus, what is it? 3 minus 2 is 1. When it goes to the other side, it becomes negative 1. So A equals negative 1. So here we have found out the values of A, B and C. All that I have to do now is substitute these values of a, b and c in equation number 2. Yeah, pi 2. Yeah, this is exactly the same as this one. This is equation number 2. Yeah, here. So you can see a pattern repeating. Yeah, okay. So if I substitute it, there is more space. We can use that for pi 3. Yeah, okay. Let us, so pi 2 equals L power a is -1 times c power b. B is also -1 times rho c power c. C is also -1. -1 times mu is as it is. Yeah. So pi 2 equals all these -1, it means they are going to be in the divide. So mu as it is divided by L C rho. That's it. This is the pi 2 term. Yeah. Again, I'm going to do exactly the same thing for pi 3. Let me do it for pi 3. What is pi 3 equation? Pi 3 equation we already know from here. Look at this. This is pi 3. Let us call this as equation 3. Yeah. So let me write it down. So pi 3 equals, yeah, L power a times c power b times rho power c times k. Yeah. Have I written correctly? L power a, c power, exactly. Yeah. Now, if you think of it, my dear people, all this pi 3 is nothing but m power 0, L power 0, t power 0, because it is dimensionless. That's the reason. So m power 0 means it has no dimension in m. L power 0 means it has no dimension in L. T power 0 means this term pi 3 does not have any dimension in time. That is what it means. Yeah. So what is L? Again, it's exactly the same thing. Do you see? Exactly the same thing. This is why we call L, C and rho as repeating variables, because they are repeating in all the 3 pi terms. L, 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 C, 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 rho, rho, rho. Yeah. The non-repeating are R, mu and k. Yeah. Okay. Let us write it. L is L power a times C is nothing but L t power -1 power b times rho is m L power -3 c times k. What is the dimension for k? It is m L power -1 t power -2. So m L power -1 t power -2. Now all that I'm going to do is I'm going to expand on the equation. M t power 0 equals L power a times L power b times t power -b times m power c times L power -3c times m L power -1 times t power -2. Yeah. Okay. Now let us equate the powers. Again, first I'm going to do m, t and L because I find it easier. Yeah. You can also do that as well. But if you want, you can start with t, you can start with L. It doesn't really matter. I do it as m, t and L. So let us equate the power for m. So here we have 0 is the power here equals, let us find all the m terms. 1, 2. So c plus 1. So c equals -1. Yeah. Let us look at the term for t. So t is the power is 0 equals, let us find all the t terms. 1, 2 t terms. So here it is -b, -2. So b equals -2 goes to the, well, minus b goes to the other side and becomes positive b. So it is -2. Fantastic. Now let us look at L. 0 equals, what are the L terms? Let me change the color so that it's easy for you guys. What are the L terms? 1, 2, 3, 4 L terms. Yeah. So it would be A plus B, because it is positive. Yeah. Positive, positive. So plus B and negative 3C, negative 1. Yeah. Let us substitute all the things that we know. We know the value of C and B. So 0 equals A minus 2 minus 3 into minus 1 minus 1. I've just substituted the values for B and C. Yeah. So 0 equals A negative 2 plus 3 minus 1. So A equals minus 2 minus 1 is minus 3 plus 3 is 0. So I get A term as 0. There is no mistake in it, So we have found the values for A, B and C. Now let us substitute everything in this equation, because we used the dimensional analysis to find the value of A, B and C. Yeah. So now let us substitute the values of A, B and C in equation number 3. So what would we have? Pi 3 equals L power A is 0 times C power, the value of B here is negative 2 times rho. What is the rho? Is the value is C. C value is negative 1 times K as it is. Yeah. So pi 3 equals L power 0 is 1. So we can just cancel this out. So we have, if I am writing this, it would be K divided by C square times rho, or rho C square. Yeah, that's it. So now, my dear people, we have found the values for all the different pi terms. We have the value for pi 1, we have the value for pi 2, and also we have the value for pi 3. All that we now have to do is we have to put all these things together. So what is let me show you guys something. Where is it? Maybe it's not there. Okay, anyway, so let us put all these 3 pi terms together. So function of some function, we do not know what is that function. Function of what is pi 1? Pi 1 value is R by L square C square rho. Yeah, R divided by L square C square rho, comma, what is pi 2? Pi 2 term is mu divided by L C rho. Okay, mu divided by L C rho, comma, what is pi 3? K divided by C square rho. All of it is 0. Yeah, that is what it means. So now I can rearrange this as R divided by L square C square rho equals, because if you think of it, the question is all about finding the R, is it not? Finding the what is it called as? Finding the value for the resistance force R. That was the initial question. I know we can easily get lost, is it not? But this is our dependent variable. So that is why I am writing it here on the left hand side, equals some function of some function. This is not a diameter symbol, it means phi. Yeah, it's a function of, I'm just writing all these things, mu divided by L C rho, comma, K divided by C square rho. So if we want the value for R, I can write R equals, yeah, L square C square rho function of mu divided by L C rho, comma, K divided by C square rho. That's it. This is the solution. Again, I want to assure you, my dear people, I know this is long-winded process. Yeah, I know. But then if you think of it, it is long. It has taken us 30 minutes to explain this because this is the first time that you might be doing it, and I was taking you through step by step. The thing is that once you get used to it, you'd find it so very easy. Yeah, you'd solve it in just 10 minutes or so. The most important thing for you is to select the repeating variable and the non-repeating variable. Yeah, as soon as you've done that, all that you have to do is solve for the a, b and c in the pi 1 term, yeah, and pi 2 term and pi 3 term, and substitute those a, b, c in the respective pi terms, and based on that you can form the equation pi 1, pi 2 and pi 3, and then you can just put them all together. That's it. Yeah, of course you will have some questions about how to do it. We will explore that in the lesson and in the tutorial, but now I want you to have a flavor of what dimensional analysis is all about. Is that okay, my dear people?